So can you start?
Okay, we can start. So
Yeah.
I think first both Ankita and myself we will introduce ourselves briefly, and yeah, then we can proceed from there. So yeah, I'll start here. So first, like to briefly introduce myself, my name is Sanjay M. Thomas. I studied in Model from 2011 to 15. I was in the computer science batch. And immediately after that, I joined Oracle, where I worked for 3 years in Trivandrum. And following that, I um, went for my master's in computer science at Stony Brook University in New York, where I studied from fall 2018 to December 2019. And after I graduated from there, I've been working at Amazon in Seattle for the past 6 months. Yep, that's about me. Ankita, do you want to go?
Okay, yeah. So I was in the 2016 CS batch from MEC, and after that I joined Yahoo in Bangalore as a production engineer. Worked there for 2 years, and after that I went abroad for my MS to North Carolina State University, and there I interned at Red Hat once I joined, and after that, this May actually I got converted to full time there, and now I'm working at Red Hat, and that is the very brief overview of how I got here. So yeah, so yeah.
So this is a ninth session of AlumConnect hosted by Excel 2020 in collaboration with MACS and FOSS MEC. I'm Megha Casey of CS6A.
And I'm Varun Krishna of CS4A. We will be hosting the session. Hearty welcome to everyone.
Yeah. So let us firstly introduce our clubs. MEC Association of Computer Students, MACS, was created by the students of the Department of Computer Science and Engineering. MACS was conceived with a vision to inculcate aptitude for the subject among students and create an awareness about the intricacies of the field. It aims to educate the students on the advancements in the industry and learn concepts that aren't part of the curriculum. MACS facilitates the participation of students in inter-college events and initiates similar events in the college. The association is presently involved in a couple of projects and activities that are associated with the day-to-day functioning of the college. It maintains the web, mail, and DNS servers in the college along with the official website.
FOSS MEC is the free and open source cell at Government Model Engineering College, Kochi. It is a community of open source enthusiasts with insatiable thirst for knowledge and are working hard to spread the acquired knowledge. It focuses on cultivating collaborative culture among college students as well as society at large by programming and contributing to various open source projects.
I know that you all are desperately waiting to hear from our esteemed guests for today. We are indeed very fortunate to have with us Sanjay Matthew Thomas and Ankita Thomas. Without much delay, let's kickstart the session. Varun, can you start?
So my first question is to Sanjay. How is it working under Professor Steven Sciena?
Okay, so for those of you who don't know, Professor Steven Sciena is a professor who is very well known for his work in algorithms. He had written a book called the Algorithm Design Manual, which is a very sought out textbook for like preparation for algorithms and like for practicing for coding interviews in general. You can say that Google has advertised that this book is the #1 way for you to crack the Google coding interview. So it's very well sought out and very famous. And so he is an extremely esteemed person in the academic community, in the CS academic community. And to state a bit more about himself, yes, first thing, he is very well known for his work in algorithms, but currently he is also working in data science. That's his primary focus as of right now. So that's what I did under him. I worked in his data science lab at Stony Brook University. To say a bit about him, I would say he is a man who is able to break things down to, like, even though he might know quite a bit about the subject that is being talked about at any given time, he knows how to break it down, like extract the most important thing in it and tell it to us. So we have a clear understanding of what we need to do almost immediately as soon as he starts saying something. So that was something that I found personally very helpful when I worked in his lab. Other things, yeah, he knows how to, like, what can you do about a particular project to make it more visible outside? Like, how can you get a lot of people interested in this, invested in this? So, yeah, that's the basics of what it's like to work under him.
Okay. The next question is actually open to you both. How important is the academic syllabus for placements?
I can go first on this. So the main thing about placements is that they look first at your industry experience, then at your academic projects, and then at your academic syllabus. At least this is the case for computer science students. It is a little bit more specific if you want to go into specialized roles. For example, if you are going into RF design, then obviously you need to take courses that are aligned towards that. If you want to go into data sciences, then you have to have projects that are very, very much in line with that, or you have to have an extensive course history showing your skill in that. But a lot of it is really dependent on like your work rather than what you've taken. It is always good to take courses that are more aligned with what you're interested in, because you will be more interested to actually work on those as well, and you will also learn things that you actually want to learn. So yeah.
And for my opinion, what Ankita said is definitely true. Like, the work that you did in the past is what ultimately they look at much more than your academic profile. We were sort of taken aback by that too. Like, we expected the academics to be more important. But to add on to that, like, in fact, academics can play a key role if you streamline, if you like figure out right now what subdomain of computer science that you want to be invested in and focus on courses related to that. That will have like a significant impact. For example, as Ankita said, like, if you want to go into machine learning, you should take, if you continue to take courses related to that, work under a professor who is working in that field and who is like if he's reputed, that's better. If you do this, if you have projects to your name, that could have significant impact. Like, you should not be discouraged if the current work that you're doing or the work that you start out with is not related to the field that you ultimately want to go into. You can always get into anything, but for that you need a lot of passion and dedication.
Okay. That brings me to my next question. How is learning computer science different from our college and like learning in a
Excellent
US?
question.
Well, from what I can see, the main difference is that the number of written assignments are very, very less. It is a huge bonus for me. It's mostly all practical work you learn from your assignments rather than just writing things down from random sources. So that is really a big plus. Another thing is that the professors just tend to lecture somewhat tangentially to the topic sometimes. It's not always per se based on a book or anything. The professors all have their own syllabus. So you could have two people teaching the same course and have completely different exams and completely different syllabus, in fact. So everything is actually highly dependent on the professor themselves. So that's a big difference, but it's also a lot more challenging because of the amount of practical work. And there's a lot more emphasis on teamwork here, at least from what I've seen. There are a lot of professors who make you work with a lot of different people in order to build up that, skill of teamwork, in order to actually lead a team and to work with other people. So that is something that is very different from what I felt. I mean, we had in India. So
So just just to give a practical example for that, like we have operating systems both here and there. In model, so just a disclaimer, I studied at model before KTU came in. So maybe the syllabus is slightly different, I don't know. But when we studied at model for operating systems, we had a textbook. It detailed all the components from a 1990 textbook. So that's the level of knowledge that you got from that. And there was nothing practical. You just read the textbook, memorized it, went and vomited it out into the exam paper. That's basically it. But here, what they would ask you to do is, yeah, as Ankita said, it depends on the professor, but they would always ask you to do something practical. So one professor, what he asked us to do was, he asked us to build an operating system from scratch. Like he gave us some basic modules that are present in the Linux shell, but other than that, you have to assemble everything yourself. So that is like, it's like, I don't know, you can't even compare the two. And like, it could also be easier. Some cases it could be like implement a system call, implement a very complex system call, implement an OS interface. So that's basically it. Like, it's much more practical. You learn a lot more. It's much, much harder. You will have to invest quite a lot of time into it. You might, in fact, spend 2 or 3 days sleepless. So good luck.
Okay, right. How did you both prepare for your placements? Were there any particular resources that you would like to recommend to your juniors?
One thing I can say is that if you are a CS student, then
No, just wanted to clarify. Is this about placements? This is about placements in India, right? Or is it here?
You could say both.
okay. In that case, one major thing would be to prepare for the initial screening. So that could be either the coding round that they give, like for example, TCS has their code vita, Oracle has their own like coding round. Every company almost that comes to MEC has their initial round, right? So there is a similar system here as well. So that once you, I mean, if you don't get past that initial, programming test, you're not going to even make it to an interviewer. So that is something you really need to focus on. Just getting it through that initial round. So for that, there are a lot of resources available. A site that everyone uses here is LeetCode because it has a lot of company-specific questions. So there's that. And after that, it's like you really have to know your profile and you have to know what the company is looking for. So if they are looking for example, a software developer, then you have to show that you have experience developing things. You can actually build a project. You have worked with people before. If it's an academic setting, you have to sell that. If you have industrial experience, even better, then you can highlight everything that you've done there. But a lot of it boils down to don't just say, I helped with this, I did that somewhat. Don't be vague, but put like solid statistics in so that they can at least get a feeling of what impact that you made. So that is really important as far as I can tell. But besides that, it's really work on your profile by working on academic projects, working on open source projects if that's what you're interested in, or even personal projects. So it's all about the work that you do rather than yeah.
So just to add on to that, I would say what I did practically is for preparation, I would go online. As Ankita said, LeetCode is a good source for this. But like, what I would do is I would look at some of the questions that come up for these interviews to understand what is important for that particular company, like what they are looking for in interviews. There are general patterns there, like Google would be more interested in trees. Amazon would be more interested in, I think, sorting. They look at that quite a lot. They will ask questions about scale. So these are things that you would want to look into. What is the company interested in? What is the company looking for when they put up a particular post? So yep, that's a good thing to like. And in general, you can like get your coding skills up. That's pretty good. What I used to do was every Excel, I used to participate in hash include. I used to participate in what to say, the lot of the code that was there. Then there was also the
4 into 120.
what is the
4
other
into
one?
120?
4 into 120. No, the other one in which you have to solve cryptography based
Uh,
questions.
yeah, Hackmaster, I think, right?
Hackmaster. Yeah, that's it. I used to do that. That was a good way to like keep myself sharp when I was in MEC. And like, you can even participate in competitions hosted by other colleges as well. And the good thing is if you do very well, if you start doing very well, you can start winning prizes. So there's an added bonus there. So that's it.
Okay.
Okay. Okay, so let's move on to the next question. In the present scenario of COVID-19 pandemic and lockdowns going on, how do you think a computer science student can best utilize his or her time?
Well, right now, the best thing that you can do would be to keep your programming skills sharp. Um, there are also options like if you want to, learn something extra, you can take online courses. There are a lot of, resources available for that. And a lot of them are provided by reputable universities and are just good for like learning more. I think we took a couple of courses on Coursera as well, and those are really good. Like there were introduction to algorithms, and there were
When
courses.
we were in MEC, like we took Ankita and me, we used to take courses in the second or third year, and like towards the final year as well. It was like a good experience.
Yeah, it's an interesting thing to work on as well. But besides that, if there are any side projects that you want to do, you can also focus on that. But mainly, it is these things, I suppose.
To add on to that, you could also work on projects yourself as a group within your class, among your classmates, or you could like contribute to a programming community. So a good example would be Swatantra Malayalam Computing, who are also like present a lot when I was there for the Google Summer of Code. Like most of the applications from our college go through them. So it's good to like look at their website, find any projects you're interested in. You can contact them. They are very helpful. They will guide you on how to like get familiar with the tools and how to actually contribute.
We have a question from the audience. Joel has asked, is there any improvements you wish were made in the CS department to better enhance technical learning?
I guess the main difference that I can think of would be that it would be nice if the assignments were less written and more programmatic. That way, we would have benefited a lot more. Like, but it is actually very time consuming. That's true, and especially when you have a full day course load like that, it's going to be very difficult to do. But even like simplified assignments, uh, but again, this really depends on like availability of the labs and the infrastructure that we have. So with what we have, yeah, I think the main thing that we need would be an increase in the lab infrastructure so that we can have courses that are more technical. So yeah.
Yeah, I don't know if it's realistic, but what I saw here is that most of the colleges, like they try to copy content from colleges which are like more prestigious. Like they look at the kind of syllabus that they have, the more prestigious colleges, and try to copy that over to their syllabus. So that's something that could be adopted in model. So I was actually I wanted to clarify, like, are you referring to things that can be changed in the model engineering college syllabus, or things that students or MACS can do to better prepare students? Like, what was the question there? Both. Okay. Yeah, that's so. My answer is and Ankita's answer is more about like what the the teachers can do, like what the courses can be, how they can be modified. And other than that, yeah, contributing to open source projects, that's a good way to learn. You learn about coding standards. You learn what are the best things to, like what are the best tools to use. You learn from people who have been in the industry for quite some time, who have a treasure trove of experience that they are almost always willing to share. So that's a good start.
One good way to get started with that would be if there is any, open source project that you use, that you have used in some other project of your own, then that is always like, something you can give back to. So usually if you go to their repository, you would find links to the community, the places where they have meetings, their email threads, and also a lot of their issues will be marked as, some of them will be marked as good for beginners. So that's also something you can take up. But yeah, a lot of it is about community. So joining their mailing list and keeping track of what they're talking about is definitely helpful.
So I think we can wrap the session. On behalf of all the organizers and audience, we'd like to thank Sanjay and Ankita for spending their valuable time with us.
Yes, indeed. We are extremely glad that you both could be here with us. Let me also take this opportunity to thank each and everyone who took part in the session with utmost enthusiasm and interest. We have reached the end of the session. Good day and stay safe.
Thank you all.
Thank you all for joining.